Welcome to Municipal Adoption of HDPE, the third webinar in a series of 4 provided by the Alliance for PE Pipe and Core Maine. Please note that this is a sponsored event and any opinions expressed are those of the presenters and do not necessarily reflect the views of ASCE. ASCE also asks that presenters and participants refrain from discussions surrounding competitors and pricings of products and services. And now it is my great pleasure to welcome back for the third year providing valuable HDPE sponsored webinars with ASCE, Peter Dyke, Executive Director of the Alliance for PE Pipe. Welcome back, Peter.
Hey, thanks, Robin, and thank you for hosting another professional webinar for us. We're delighted to support this program because you guys do such a great job. And welcome, Richard Colassa. Richard, could you come on? You're also a sponsor at WL Plastics. Welcome. Can't hear you, Richard. All right. So
sorry about that.
Okay.
Sorry about
welcome,
that.
Richard.
Thank you, Peter. I'm very, very excited to be here today. This deck should be very, very informative to everybody that comes on this call and give them a lot of insight to the aspects of polyethylene and the adoption of in the municipal areas. And we are seeing a lot of that, and I'm very, very excited to have this presentation today. Thank you for
Well, you guys make the pipe, Richard. You do a great job. Thanks for all your support, and please contribute. And I know that you'll be on the bench as well answering questions. And as Robin says, we have several people helping answer questions as our engineer, Alan Ambler, takes us through this deck. Okay, Alan, let's see some slides here. And Rusty, could you come on and introduce yourself, please? Rusty Reeves from Corin, Maine.
You bet. Yeah, Rusty Reeves. Corin, Maine really loves to support the both ASE and the PE Pipe Alliance to get this education out there and just help demonstrate just how good HDPE piping systems can be. So again, thanks for the opportunity.
Yeah, and Rusty, please contribute as well. So Alan, I think your deck is on presenter view. If you could figure out how to switch it to the other view, that would be great. So the Alliance for PE Pipe is a trade association, and our mission is to educate engineers and municipal users about HDPE pipe and its use in municipal settings. Alan's worked pretty hard on this brand new deck, and we're excited to bring it to you today. We have a very active webinar program. We do 15 webinars a year. We have a YouTube page, which is very busy, a lot of very thorough videos as well as some really quick ones. Go ahead, Alan, to the next deck or the next slide. And then we have a lot of members that contribute to our organization to keep it going and allow us to do this kind of thing. All right, so it looks like we're starting to lag. Hey, Dan, can you take over the slides?
Yep.
That would be, yeah, right. That would be great. Sorry, guys, we'll get this sorted out. All right. Okay. How's that looking? All right, go to the next slide. So these groups of companies fund our operation. We'd love to have engineers and municipalities join the organization. That gets you closer to our operation and what we're doing. Go ahead, Dan. We also have a tremendous social media presence. We got 17,000 followers. I guess that doesn't seem like a lot when football players in college have 1 million. But LinkedIn is where we get the most activity. So follow us on LinkedIn. We post every single day. We're also down here in Florida today doing a live road show. We'll be in Collier County tomorrow and then up in Tampa the next day. And then we head up to Canada for 9 different shows. And then Alan and I will be back with an HDPE above ground webinar on October 4th. We look forward to that. So we have an active ground game as well. Alan, could you come on, introduce yourself, and tell us a little bit about the engineers package?
Hey there, Pete. Hopefully you could see me. Not sure if you can. The engineers package is something that we have available for everyone that's out there that has a massive resource for you. We do have the Plastic Pipe Institute Handbook on Polyethylene Pipe and a searchable PDF, an insider's guide to HDPE. We have specifications that are written for you covering horizontal directional drill, pipe bursting, and otherwise and then also typical details, both in AutoCAD and PDF format for your review. So lots of different resources in there to be able to help you in your polyethylene journey.
Yeah, for sure. So you have to ask for that, and you can write a note in a Q&A and say, hey, please send me that. And then, Dan, how does everybody get their PDHs?
Yeah, so all requests for information, PDHs, please put it all in the survey. Please don't use the Q&A function. The easiest way, the quickest way for us to get everything over to you is to fill out that exit survey. And I'll get to everyone's request by the end of the week, I promise.
Awesome. Next slide, please. Okay, and we also have case studies. That's important. Next slide. We have over, I think, Dan, I think we're at like 500 slides now. Well, if you could come in and Jared, come on and introduce yourself. Tell us a little bit about what you do for MUD out in Omaha.
Sure. Yeah. So I'm Jared Sfigera. I'm the Director of Infrastructure Integrity for MUD here in Omaha, Nebraska. So my team basically kind of handles the risk assessment and the replacement of all of our water infrastructure.
You can do it right here.
Yeah.
Awesome. All right, I'm going to give my seat, Jared, to Alan because he's having technical difficulties.
Hey there, guys. Sometimes, we have trouble on the road here, but here's Rusty Reeves. If you want to come on and tell us a little bit about Core and Main and what they may very well bring to those municipalities out there that want to adopt HDPE or do a new install.
You bet. You bet. Yeah, Core Main, we're a leading specialized distributor of water, wastewater, and storm drainage and fire protection products,
Why don't we just
as well as the services. We've got 320 branches across the country, coast to coast, and about 4,500 associates. I personally have been involved in polyethylene over the last 30 years. So been helping Core and Main. We've got over 600 fusion machines, technicians. We've got any repairs, anything like that need to be done, as well as all the valves, fittings, anything that you would need to incorporate into your project. And we're excited about all the no-dig projects that are really growing and seeing more and more in the municipalities. And HDPE is just a perfect piping for those. So again, look forward to helping people learn about it and educate them on the polyethylene systems. So thanks for the opportunity.
We look forward to that too as well. So very happy everybody's here. Definitely part of it. So part of the success of the Alliance for PE Pipes program here for us is we kind of run two parallel webinars for you. So we run one that you're seeing us talk through these issues, but we also have lots of people that are on the bench for us. Go ahead and advance the slide, Dan, so that way we can see your picture. And Richard, Matt, and Dan Landy, who you've seen on camera, are behind the scenes. So don't hesitate to ask any of those questions for you that are burning and you really need to know about it, because these three gentlemen are going to be behind the scenes answering those questions live for us and being able to make this much more involved in that manner. So if you have a burning need to contact us, here's a whole list of contacts for you. Definitely email these individuals. They love high density polyethylene and love to talk about high density polyethylene as often as they possibly can, and then answer you and talk through your project as well. So if you had any obviously CUs, any type of PDHs, Dan's told you about that. It's best and quickest to put it in the survey for us. But if you want us to be involved in your high density polyethylene project, all of these individuals would be able to help you through that process. Back to what we're talking about. Municipal adoption of high density polyethylene. 16 years ago now, I started in the city of Castleberry as a utility manager. One of my first times being involved in all things utilities and being able to install infrastructure projects. And boy, I tell you, I just absolutely loved high density polyethylene through a trenchless technology method called pipe bursting. Go ahead and advance to the next slide. So we're going to talk through lots of different projects that have happened and why we love to talk about high density polyethylene success and share it. Here is a list of acknowledgments of lots of different municipalities that have contributed to the program that the Alliance has to be able to show you out there actual project installations and talk through those installation things that we really really need to be able to learn about high density polyethylene itself. So thermoplastic is what HDPE is, and it allows for repeat fusion as we come through. So you can fuse that pipe together. We're really heating that that high density polyethylene material to a specific point, and then allowing those molecules to flow across that surface. And then itself, that joint becomes as strong, if not stronger, than the pipe itself. So what you're seeing here is what happens during the fusion. We have semi-crystalline areas that are solid after it's cold through that. Then we're allowing that pipe through fusion, through contact of the surface, to be able to fuse and run across that. And it leaves us with a joint that is as strong, if not stronger, than the actual joint itself. So here we go. What this does is it allows us to be able to not have fittings or other things of that nature when we have polyethylene systems from point A to point B. Very good process to allow us greater productivities and longer pipe runs when we can look towards trenchless applications. And we can actually open cut more areas as to which we would allow more installation and greater productivity in that manner. Go ahead, next slide. That is unique to polyethylene in itself. Two regions that I had mentioned before is the semi-crystalline and the amorphous region. Those two work together to be able to bring us the density that we need to give us a high pressure rating, resist that occasional and recurring surge pressures. And then it also gives us that amorphous region, which basically keeps all of these parts and components together and really allows us that viscoelastic behavior to work with it in the field. That's defined by two things, this creep or deformation of the actual material, and then stress relaxation. Creep comes when we actually deform the material. High density polyethylene has high limits of deformation, but what we're seeing is once that stress is actually relieved from that point itself, then that pipe relaxes. That's why we can actually field bend this pipe in many instances. Once it's got a new shape as to what we're seeing, then we release that stress, and then that pipe thinks it's a happy pipe. So as you're seeing in some of these videos and the pictures, the one on the bottom right happens to be a temporary condition as to which we are temporarily raising and elevating that pipe to get it aligned to go into an excavation or pipe bursting process and procedures we come through. And then once that pipe is installed, it relaxes and it's installed very happy pipe in that manner. So go ahead and advance to the next one, please. So we want to look at main lines and open cuts. AWWA provides us an M55 design window. And what that does is if we stay within a 2 to 25 feet depth of installation, and we are DR17, I'm sorry, DR7 through a DR21 pipe, you don't have to do any calculations whatsoever through it. The video that you're going to see now happens to have all those things that we want to see in a trench. Those happen to be a foundation, and they happen to be a bedding that's a soft place to be able to put the pipe down on it. And then you won't see it in the video, but then they compact that pipe as we go through. So this is one of the productivity things that we see with long installation methods and open cut, as you're seeing, is we don't have to have people in the trench to be able to work on that pipe as we go through, and we could take advantage of long laydown areas itself, or long installation areas for higher productivity as we come through. Go ahead, next slide, please, Dan. Horizontal directional drill is often a very common way to be able to have someone's first introduction to high density polyethylene. It's done in one of the most challenging conditions as to which we're going to see HDPE installed. So oftentimes we're trying to clear an obstruction, either a riverbed, water body, or something of that nature, in which case we go underneath that obstruction in a clear path. That's obviously we're researching and designing that path as we come through. But high density polyethylene allows us greater tensile force in order to be able to resist the friction forces along that pull path as we go through and come out to the other side successfully. So that viscoelastic behavior, again, permeates all of this action as to which we're pulling this pipe into place. Pipe bursting is another situation and trenchless design that really helps us to be able to eliminate more excavation as we go through. We can all trenchless as a family go 85% less excavation, but in pipe bursting, we're taking advantage of an existing conduit location. We know that it's free and clear of third-party utilities. We're able to come through, fracture that existing pipe. That existing pipe stays within the 2 to 3 inches of soil surrounding that replacement pipe, and now we're getting that production run as we come through. We're limited in pipe length ranges by either valve to valve spacing in potable water distribution systems, or in manhole to manhole spacing in gravity sewer systems, as we see there. So there are some limitations to the technology, but once we understand what those are, we can ensure productivity as it goes through. Slip lining is another method. When we cannot fracture that existing pipe through pipe bursting, then we can pull in slip lining. So we need to access the pipe. We need to make sure that it's clear and free of any tuberculation or anything that might obstruct the idea of that pipe, that gives us a nice avenue to be able to pull that pipe in. Now, this is a replacement technology or rehab technology that reduces the ID of the existing pipe. So we can't put back something larger than that existing pipe. Pipe bursting is the only rehabilitation method, trenchless wise, that can replace with a larger OD than the existing pipeline. But in many instances, slip lining really helps come through when we have long runs and larger pipe and then more of a transmission application come as we go through. Go ahead, advance. Compressive fit slip lining is a very unique application itself for high density polyethylene, as we are temporarily reducing the OD of the production pipeline by pulling it through a dye reducer. So we are pulling this pipe, HDPE pipe, through that dye reducer. So you're seeing here, once it gets to it, we're reducing the OD of that pipe, pulling it into place. And then when we're done with the pull, we allow it to relax, and it'll come back and retain its shape from the existing condition. So it'll push up forcibly against that existing pipeline as we go through. Compressive fit slip lining only uses high density polyethylene pipe, and it is a very cool technology to be able to maximize that ID as we've gone through. So here's valves. One of the things that I'd like to talk to, and Rusty, come on in if you want to talk through valves and available things that Core and Main might have. What you're seeing on the bottom right happens to be an MJ adapter. Fusion in itself needs to have dry conditions. So if we have a repair or something like that that doesn't give us a dry condition, or there's just moisture we can't really get rid of within the trench itself from dewatering or from over excavation stabilizing that, where we would use this MJ adapter to be able to make that connection. But Core and Main offers lots of different valves and connections, and Rusty, maybe you want to elaborate a little bit over that.
Yeah, I was going to mention that, and like I said, I've been in this over 30 years, and there was a time that it was difficult to find the right fittings and find things that would work with polyethylene, and that is certainly not the case now. There's multiple manufacturers of fittings. You can get hydrants with polyethylene stubs. I think if you can utilize the fusion method and do the fusion for all the polyethylene connections that you can, you get a better system. But however, we've got electrofusion available. You've also got many different types of mechanical joining, just like you mentioned, the MJ. So you can really get anything that you need that's required at this point in time. Again, for flushing, for doing bypasses, I know a lot of the rental companies that help with temporary bypasses utilize the pipe. They drag it around on the ground because it's such a durable piping system, and you can do whatever type of valve configurations you need. These HDPE stubbed hydrants, like I mentioned, and there's now valves as well that you can just do the fusion directly in line. And again, you can always refuse a line if you need to. Any type of a connection, you see the photo on the right there where you can seal off, like in a manhole or wherever else. You can then come back in with grout and water protected there, so you've got that completely sealed off. The electrofusion you can see there, it's a very small machine. You can drop down in ditches to do that, but you've got pretty much any valve available. And then you can get into the service lines as well. Again, you would have, you can do butt fusion on that. You've also got electrofusion for doing your service fittings, or you can do a mechanical. Say you've got where it's a little bit dirtier situation, you have a smaller area to clean off and utilize those mechanical connections for the service lines as well. And then you can tie right back into polyethylene or brass or copper heading into the homes. So the other thing, maybe you touch on this later, but the pre-chlorinated lines for a lot of the system can take place as well. So here on the left, you see the electrofusion coupler there, and then connecting to that service line. This one, you can do the hot taps there on the right. You're able to go down and actually have that line in place and do your tap and then make your fusion to the connection. And you've got water flowing in just a very, very short amount of time to get to that service. To that house.
Dan, go ahead and go back to the previous slide for me. So in that service connection, most of the knowledge and application of high density polyethylene came, we learned a lot in natural gas, and medium density polyethylene. So
Correct.
we wanted everything to be fused from point A to point B. When we started to recommend here is failure or leakage of natural gas has a very different implication than leakage within the water system. So the industry in the past 10 years has come a long way, as Rusty had mentioned. And now we're making a lot of fittings that go with those standard brass inserts that you really want to use in corp stops, and give the municipalities a lot of different options. Glad you mentioned pre-chlorinated, Rusty, as Jared will talk about that quite a bit later, because they've implemented quite a bit of that going forward too. So thank you, Rusty.
You bet.
Advanced Dan. All right, so an electrofusion fitting, we talked about that thermoplastic behavior, butt fusion, when we're prepping that surface as it goes through. Electrofusion is a fabricated fitting that does the same thing from a raw HDPE standpoint that we're looking at, but does it with copper wires that are copper coils that are embedded within the fitting itself. And we have it's a molded fitting and not a fabricated fitting, but a copper wire embedded. There's a hot zone and a cold zone, and when it heats that polyethylene material, we allow that to go across that hot zone to cold zone interface, and then the end result is what we're going to look at, the same as extruding a pipe or butt fusing a pipe as we go through. And a lot of these fittings give us that ability to be able to use whatever service connection that you are used to in the field that way and have a history of. So they do have self-tapping services, self-tapping fittings that you're seeing here, to which they'll cut down a coupon out of that pipe, hold that coupon, and now you've got a live tap coming through to be able to provide your service connection with a live main, so you don't have to shut down that main as you go through that. Go ahead and advance to the next slide, Dan. So service piping with tracer wire. So they make that service piping on longer coiled up runs, in which case they attach that tracer wire to it. Tracer wire is necessary as plastic materials do not convey that electronic signal that allows you to be able to identify it with locating devices as through here. So oftentimes in delicate pulls where there's lots of forces going on, we suggest multiple tracer wires to ensure that they survive whatever pull you're going through and still continue to allow you to locate that infrastructure pieces you're putting through. There's also RFD balls, and those send a signal to the surface as to where that pipe is actually located. So there are any preferred option that you have out there for what it is that you want to do with HDPE is available to you. So except for, of course, large fire hydrants or gate valves that have a lot of metallic pieces and things of that nature. But MJ adapters, or those things that we were talking about, flange adapters, can attach to that fire hydrant and be able to carry on with your project as you're going through. So go ahead and fast forward. So here's some other examples of just cut sections. There's lots of products out there to be able to provide exactly what it is you need. And I believe we're getting to Jared pretty soon here, so we can dive right into that municipal story. Advanced Dan? Again, the strength of that fusion is we're seeing they're raising the forklift from a saddle that's fused onto a mainline pipe. So this is a simple display. Of course, it's not an ASTM test that's showing you, but they're showing that strength of that fusion. Once we're fused onto that side saddle, that we're simply not going to pull off from that. Go ahead and advance to the next slide. Compression fittings are another example of exactly how you can connect the services as well. So oftentimes in other pipe material types, copper, you can use a compression fitting to be able to attach that to your service or the next service down if you need to extend that service and go through there as well. So here we go, Jared. Come on and tell us about what's going on in the Metropolitan Utilities District, and we're so happy to have you here.
Yeah, thanks, Alan. So yeah, I'm Jared Sfigera. I'm the Director of Infrastructure Integrity for the Metropolitan Utilities District here in Omaha, Nebraska. So the Metropolitan Utilities District, or MUD, is a public utility that serves the city of Omaha, Nebraska and the surrounding towns. Our water service system is made up of 3 water treatment facilities serving over 600,000 customers through over 3,000 miles of water mains. Our water mains currently are consisting of mostly ductile and cast iron pipes. MUD is also the gas company for Omaha and some of the surrounding cities, with nearly 3,000 miles of gas mains made up of mostly HDPE and steel pipe. Next slide, please. Now, since the topic of today's webinar is focused on our adoption of polyethylene, I wanted to open up with a bit of history of our use of that material at our utility. On the gas side, we've been installing HDPE for decades, but really increased with the advent of our Distribution Integrity Management Plan and our program to replace our cast iron infrastructure. HDPE on the water side has primarily been used for creek crossings, given its exceptional deflection capabilities, and we still use it for creek crossings for both water and gas today. Now, in 2016, we hired Murphy Pipeline Contractors to slip line a 24-inch cast iron main, which what Alan showed earlier on some slides, with a 16-inch HDPE pipe in a very congested high-profile corridor. And then in 2019, MUD formed an asset management division focused on reducing the cost of distribution water main replacement, having focused primarily on the gas side for many years. Now, we took a close look at all materials and methods and ultimately landed on pipe bursting and directional drilling with HDPE as the most cost-effective means of design and replacement. And now HDPE makes up a substantial portion of our infrastructure replacement program. Now, we do a lot of directional drilling of polyethylene on the gas side of the company to replace old 6-inch low-pressure cast iron with new high-pressure pipe consisting mostly of 2-inch HDPE. Now, when the pressure gets really high, around 125 psi, we primarily switch to steel, but at creek crossings, we'll still use HDPE to take advantage of the more favorable bending radius. Next slide, please. Now, I'm sure plenty of utilities have experience with HDPE creek crossings for water mains, but this is a somewhat unique scenario in that we had recently bored in that 12-inch IPS HDPE gas pipe that I showed on the previous slide. So rather than purchasing another pulling head for this 16-inch DIPS HDPE creek crossing, we commissioned a custom 12-inch IPS by 16-inch DIPS reducer to facilitate that pull. Now, the ability to create custom fittings with solid billet is a property unique to HDPE. For end connections for these larger water pipe projects, we use MJ adapters as previously mentioned to couple into that existing infrastructure. This project connected to a restrained joint ductile iron, so a collar for thermal expansion wasn't needed, but a typical thrust block was utilized to avoid movement when the valves on either side of the project were operated. So MUD has been installing ductile iron water mains using horizontal directional drilling for many years. But following numerous corrosion hole failures, we began installing more plastic pipe in 2019 or 2020. HDPE was only used along curved roads where the extra deflection capabilities could be fully exploited. However, over the years, more and more projects that were previously selected for PVC, those straight horizontal alignments, were switched to HDPE, given the ease of design and the fact that the pipe is very installer friendly. With HDPE, we no longer needed to produce profiles for our designs, given there are no vertical deflection concerns, and any field deflections that could reduce the life of a PVC main are no longer a concern. Next slide. In 2022, we entered into a contractor partnership with Murphy Pipeline Contractors. Murphy is a nationwide contractor whose bread and butter is HDPE pipe bursting. We brought them in to replace some of the highest risk distribution water mains and see how their process would work in Omaha. Now, the first step in a pipe bursting project is setting up that temporary water service. Murphy uses HDPE for that application as well. They use 2-inch HDPE above ground piping and set that up, and a service tap is installed down to the customer's existing service piping. As you can see, this process has a lot less impact on the customers, as you would assume, since Murphy replaces those spoils right back into the holes prior to pipe bursting, making for a nice clean job site. Next slide. The biggest challenge with HDPE pipe bursting is staging and transporting those long lengths of piping. So effective customer communication and traffic control is key. But Murphy tends to get creative and move that pipe when they move that pipe into the entrance pit. Typical burst only lasts a couple of hours, so disruptions to the community have been pretty minimal. Next slide. So one of the biggest benefits, as mentioned, with HDPE pipe bursting is the ability to pre-chlorinate and pressure test those pipe sections above ground. Murphy plans out that entire project ahead of time and labels each length of HDPE. Each length is then pressure tested and disinfected days prior to installation. And after the pipe is installed, the end connections are made to the existing system. We choose to keep that area isolated and pull additional back T samples. It just has an added assurance of pipe cleanliness, but service connections can be made that day. This avoids costly days of waiting for mains to pass back T testing before the project can progress. Now, I worked closely with Murphy to develop a custom project log for our projects to ensure that the testing procedures adheres to our standards, and an MUD representative has always been on site to witness that testing.
Jared, it's Peter here. I noticed that you mentioned that you used cost as a major determining factor in selecting polyethylene, as well as its deflection ability. Have you developed an average lineal foot cost for your pipe bursting jobs?
So we kind of deal more in like cost per mile. And so I can kind of share that with people if they wanted to reach out. But that's, yeah, it's definitely been a cheaper option for us in the long run.
So it's less expensive for you than open cut with PVC?
Absolutely. Yep.
Thank you.
But Jared, if I can interrupt, let's go back to the pre-chlorination. One of the things I wanted to point out definitely is because we can fuse that really long run up above ground, we're taking advantage of higher productivity the day of the pipe burst, right? When we're pushing the static rods out into the existing pipe, does that take around how long? About 45 minutes to an hour?
Yep.
And then when we're pulling that pipe back, we're about the same time duration to be able to, expand the existing pipe and pull that production pipe back, correct?
Yeah. Yeah. It sounds like about right time frame.
So that 500-600 foot run really occurs fairly quickly, and we can get a whole lot of, maybe a whole block done in a city day that manner through this pre-chlorinated procedure, in which case it dramatically reduces the time that the construction crew spends in front of the actual residents. Is that something that you can put together in a low bid, Jared, and a social cost for it, or did you guys just recognize that that's a really cool part of pipe bursting and really want to go for that?
Yeah, no, that's just inherent to that installation method. It's like you said, a lot less disruption to the community on the day of the actual installation. Yeah. So in addition to Murphy, we also pipe burst with our internal construction crews. If you go back one. So we began pipe bursting with our crews back in 2020, but started with PVC since that was kind of the pipe that our water crews are more experienced with. But after seeing the many benefits of HDPE on the Murphy project and given the added flexibility of HDPE, we redesigned all of our pipe bursting projects for the following year to use HDPE. Feedback from the crews has been nothing but positive, and that fusion expertise from the gas side of the company really easily transferred over to the water projects. Now, in these above photos, our crews were upsizing existing 4-inch tuberculated cast iron to new 6-inch dips DR11 HDPE. We found that as long as we can get the rods through the existing host pipe, we can burst it. And in this case, it was a tight fit with the existing ID just over 3 inches and the rods just about 2 inches. Our process uses a system of 3 roller cutters, which you can see in that right image, to score and split the existing pipe, as well as break open any repair sleeves. So you can just make out the roller cutters against the soil in that right photo. Next slide, please.
So I just wanted to elaborate a little bit on the types of materials that can be burst as well. I may have just pushed over it way too quickly earlier. But you mentioned cast, which is a fracturable material. Then there's non-fracturable materials such as high density polyethylene. You could still cut through it, but pre-stressed concrete cylinder pipes, a heavily reinforced concrete pipe, or something that has a matrix altogether with it, typically can't be burst in those manners. So you guys are targeting just the right pipe that can be done here, and that 3-inch is about the lower threshold. So I'm so glad to see you guys going after it. So good job.
Yeah, thanks, Alan. So then after the rods are in place, we can move that pipe string to the pit and use our ground burst 800G that we purchased last year by TT Technologies to pull that new pipe into place. The next slide. So this is a cool before and after photo of a service pit that our crews had exposed. So you can see that the existing 4-inch mechanical joint cast iron in that left photo, and then the remains of that pipe next to the new HDPE main over in the right photo. Given that HDPE is very abrasion resistant, and then the physics of the pulling head, we've seen minimal scraping on the HDPE following a burst, and never greater than 10% of that wall thickness. We also pull pipe burst specific trace wire made by Copperhead, and that's just under the pipe in the right photo, so it's not visible. Now for end connections on these smaller diameter water projects, we elect to use mechanical joint wedge action retainer glands made specifically for plastic pipe, along with an insert stiffener. We have found this to be a fast, effective, and flexible means of connecting to existing restrained infrastructure. But then when we connect to unrestrained systems, we install a concrete collar or block with electrofusion flex restraints to resist any pull-out forces. So wrapping up, I wanted to show the saddles that we use for service connections. We do elect to use mechanical saddles, and have found that the TPS triple tap saddle is the best for pipe bursting applications. This saddle is made of 304 stainless steel and features 3 independent sealing surfaces for any imperfections in the main at following install, and also allows for thermal expansion contraction. Next slide. Yeah, so I hope this brief presentation helped other utilities realize the flexibility and benefits of HDPE. This material has played a pivotal role in helping us replace our aging infrastructure in the most cost-effective and least disruptive way. So if anybody has any questions for me down the road, this slide has my contact details. Feel free to screenshot, and please don't hesitate to reach out. Thanks.
Jared, great job. I really enjoyed learning about what's going on in Omaha and the surrounding communities. Thank you very much for that. Alan, I noticed Jared has gone with a mechanical connection on his services, which you did too when you were running a utility. Could you give us what we consider the best practice, Alan, for polyethylene to keep everything fused all the way to the house?
Absolutely. So for fusion, for high density polyethylene all the way to the terminal connection, what we can look at in this size pipe itself happens to be an electrofusion saddle, and then you can either use an electrofusion coupling like you see on the left here, or they do make small little butt fusions machines as to which you could put through that service connection directly to the tap that you need, and then make that final connection. So we've been asked in seismic conditions, what exactly do you need to be able to make sure you provide and install the most robust redundant system for you. And electrofusion is an integral part of that size of pipeline itself, as well as butt fusion in this manner. So
okay, so this example, Alan, is using a electrofusion saddle with a Ford corporation to a polyethylene service, and it's connected to the corporation with a compression fitting. Is that correct?
That's correct. That's exactly what we're looking.
And then in the previous one, Dan had on there an electrofusion tapping saddle with the other one, the self-tapping tee, Alan. But now the owner doesn't get the benefit of a corporation. Could you explain why a utility would choose not to have a corporation?
Whether or not they need to have that live tapping condition at the main drives a lot of that. If they can't shut off the water main that they've installed, so in scenarios to which you have an installed water main and you come back through afterwards to install a new connection, you want to try to keep that water main running to the best of your ability, then you would use that live tapping, and then a corporation stops it from continuing to flow flow through your actual service pipeline as you need it. Later on down the run, that maybe they've installed a different stop at the meter box as to which you'd shut that water off through that. But there's lots of different options, and that's one of the things that we really wanted to convey thoroughly to everybody through this. Just a reminder, everyone, try to keep all your questions into the questions portal, so that way we can properly address those. We've got a lot of questions that have come through, and that really is part of what makes all of these systems for us fantastic. Jared, thank you so much for sharing your story. Much like many municipalities that have run natural gas distribution systems at the same time, you've learned that polyethylene is a lot of the best ways to be able to go as you move forward, and now they're integrating it into their municipal water system. So go ahead and advance, Dan, and we'll get through some more case studies for you. So
hey, one other question that came up that I think is pertinent, Alan. So somebody asked, the electrofusion tapping tee that we had was not at 12 o'clock, Alan. It was at like 2 o'clock. Do they have to be at 12, or is that air entrapment an issue?
Well, it's not necessarily that air entrapment is an issue. One of the reasons why in the field we don't necessarily put them at 12 o'clock is the teeth of the backhoe bucket. When we start to put that through, then if your service connection is coming right off at the top, then it's most likely to get dragged by the teeth of the backhoe bucket as they're trying to find where that pipe might be. Of course, we all recommend that you dig 2 feet away from any utility, but a lot of crews out there want to hand dig as little as possible as we go through in that manner. Entrapped air within that connection really is not a problem for us in that manner. Thank you very much for the live question, Pete. So Fort Lauderdale has recently implemented a fairly big project as to which they had a failure of a force main, and that force main itself was crossing a river body and was the only way that they had to cross that river body in that manner. So it was not necessarily a redundant system, which sometimes will be one of the main questions I ask when looking at rehabilitation projects. So there was the only way to bypass around this area was to use vac trucks to be able to remove the force main material upstream and then truck it over the river to be able to go downstream through it. 18-month schedule construction. High density polyethylene was used in a multitude of different manners to be able to install the pipe through horizontal directional drill, compressive fit slip lining, pipe bursting, and other things. Advance. And so this was definitely a very good project to look through, pushed the technical limitations quite a bit for installations, and was a fairly comprehensive product installation. Lots of different DR ratings and different pressure zones that they had, and lots of pushing that length limit as we come through. So 4 horizontal directional drills with compound curves. So that means there's not only a vertical curve, but a horizontal curve associated with it. 17 crossings throughout downtown Fort Lauderdale in highly congested areas as we're seeing through there to make sure that we install this replacement infrastructure, and definitely a good example of use of high density polyethylene. North Texas Municipal Water District, as we're looking through, another great force main project with 24-inch, 21,000 linear feet. Horizontal directional drill and open cut. Pete had mentioned earlier what's fairly important. Most of these trenchless installations have an open cut element. We used to think that the majority of the installations of high density polyethylene were trenchless applications. But when we started to really survey and poll our attendees, we found that open cut installation was the primary method for installation. Now, it's important to note that fusible or PVC, ductile iron, and high density polyethylene are all considered to be flexible pipelines when we're installing them in an open trench. And most of the practices and procedures that you'd use to be able to install a PVC or a DIP pipe are going to be the same for high density polyethylene pipe. So definitely out there, don't have any qualms or concerns about that viscoelastic behavior when we're installing in an open trench condition. So go ahead and advance the slide, please. So City of Miami Beach is another adopter of high density polyethylene through a low pressure force main. There was a pre-stressed concrete cylinder pipe that had been installed to be able to convey force main off of Miami Beach to a regional wastewater treatment facility underneath Key Biscayne, if I remember correctly. That piece of pre-stressed concrete cylinder pipe was failing, and the city of Miami Beach had recognized that a failure in this high tourist area would be a fairly dramatic impact to the tourism industry, and knew that they had to install something fairly quickly. So the project was originally bid as a micro tunneling project. Yes, definitely show the video. Thank you. And then it exceeded its budget and came back as a pushing the boundaries and limits for a horizontal directional drill project. So this is 4,300 feet in a heavily dense area. They basically took over an entire city street for a while and shut down that city street from through traffic to be able to fuse up the long runs of pipe. There was a break in between the pipe, as to which they could not pull it all in one section and had to stop the pulling process to fuse the pipe to continue the pulling process through that. The whole project was executed in 5 weeks, if I remember correctly, and the actual pulling process was significantly shorter than that. So Jared had mentioned minimized impact from inside the residents or customers viewing area to see that. And this is another massive social savings to be able to install this pipeline in such a quick manner to be able to minimize the impact to people. Kiowa Special Utility District as well used some pipe bursting of asbestos cement pipe in this area to be able to replace that existing pipe. In previous projects, they've also installed through horizontal directional drill lots of different high density polyethylene to be able to replace existing pipe that they've had. The horizontal directional drill essentially installed a new pipeline, and they abandoned the old pipeline in previous years. So go ahead and advance to the next slide for us. So this is a very big case study. It's temporary bypass is often a method that is highly used for high density polyethylene. This is a City of Baltimore large diameter combined sewer, 78-inch. They are going to be lining that, and during the lining, they need completely dry conditions within that pipeline. Because it's a combined sewer, they understand the gravity flow through this pipeline, but they also need to be able to have capacity for potential rainfall events through that. So in order to be able to line 78 inches, almost 4,700 linear feet of that pre-stressed concrete cylinder pipe, they needed 45,000 linear feet of 24-inch HDPE. And you could see how many different bypassing units they really had. So this is a very robust, large pipeline that serves about 250,000 people through this area in the City of Baltimore. And high density polyethylene was used heavily in order to be able to bring us through this. You'll see in this video here, lots of different ways to be able to handle and fuse that high density polyethylene. That's a common manifold that all of these bypass lines are being able to suck into and dump into. Then the crew in site just ensures productivity by continuing the fusion process. We're making sure that we get as much pipe fused as quickly as we possibly can. It's stored above ground through the actual lining process, and we're protecting that pipe in the different areas. This video really shows a good culmination of lots of different methods to be able to connect that high density polyethylene, benefits of fusion, fabricated fittings, flange fittings, as we've seen, and lots of different ways to help through a very complicated process. Oftentimes in large diameter rehabilitation projects, the temporary bypass can be significantly more complicated than the actual rehab of that large diameter process itself. So Again, when we look for temporary water on potable water bypass, as Jared mentioned, sometimes these are obviously much smaller, but we still have to protect that line, which you're seeing in the bottom right picture. We have basically a protection over it so cars don't drag across that line as we come through. And really, it's fairly common to be able to use that temporary bypass, a 2-inch line of high density polyethylene, and then move it from one block to the next as we advance and that project continues through. So go ahead and here's a very unique application for Sunbelt. They draped the high density polyethylene bypass through a live river. A leak-free joint is the only product that really could offer us this opportunity to be able to not pollute that river that you're seeing through this. So that friction loss coefficient is maintained as we're going through. These do not leak. These temporary bypass companies continue to use and reuse these pipes all the time. So that thermoplastic behavior that allows us to continuously fuse that pipe, cut it, fuse it again, really is a true benefit in temporary bypass. So Rusty, do you want to come on and talk to us a little bit about the Westminster Force Main project here that installed some new force mains to help a existing force main?
Sure. Yeah. And again, I think this project, as well as that North Texas project and even the bypass you just looked at, really shows some of the advantages of polyethylene. When you see this next slide, we've got dual pipelines going through this segment that it's in a very, very trafficy corridor. Yeah, here we go. This is the one picture I was going to show. So you've got a heavy traffic corridor there. You had the same thing in that North Texas HDD job you showed before. You've got to keep these traffic lanes open. That you just do not have the room along the coast in California to be able to close these roads down. And they're able to do this very quickly. Get this, one trench, getting 2 and 3 pipelines in there at a time. The polyethylene being able to fuse it beforehand makes it so much easier to do that. And like you mentioned on your Miami job, you're able to do a very large project that, had it been open cut, may have taken months, and shut that city down or those roads down for months and months. And they're doing these things in 5 weeks. The polyethylene, just amazing to be able to do that. This particular project, again, needed to get, they had vaults every 2,000 feet and needed to get the sewer line back up and going, as soon as possible. To increase the capacity there with all the population growth. And that's something we've seen in this area quite a bit. There's another project that was a sister to this project. It could only be done at night. So again, you had to be able to open and close those trenches, keep the roads open, and be able to get the pipe installed and moving forward by the next day.
Oh, go back one, Rusty. I wanted to make a comment as well.
Sure.
One more there, Dan. So one of the things that in open cut, actually, go to where we see the trench cross section. Essentially, when we have room to open up, Rusty, as you're seeing here, which you mentioned, once we're able to take over that median, we can open up that long length. They essentially can just open up that entire section. If everything was fused before, they can pull this in an hour. So, I mean, we're talking about maximum productivity. We often get that question about open trench because everybody's used to segmental pipe and limited trench excavation ability.
Exactly.
That's really controlled by maintenance of traffic activities more so than the actual logistics of digging trench and having trench box through it. So I'm glad you pointed that out as well, Rusty, through this process itself. So
less excavation, as well as not having a person down in that trench, which you have to do if you've got segmented and gasketed type material. So yeah, again, polyethylene and just being a monolithic pipeline through there. I mean, it gives you a lot of advantages for these projects, for sure.
Go ahead and advance, Dan, to the Belgrave, and then Richard, if you wanted to come on to talk to us about this project. I know you were involved in this one. Are you still with us, Richard?
Yes, I'm still with you. How you doing? Thanks again for a lot of the great questions coming out to Belgrave. I was just referencing this to a question. What's the difference between how frequently can you test large diameter fusions. But in this particular case, we had some real challenges because we had a not a lot of area to work with to make the initial string of pipe, and this was 30-inch diameter. So we did it on barges, and we used the waterways there to support that string of pipe that we were drilling back. And not only with that, we had a wetland that we had to go underneath that could not be touched. We were very we were observed very stringently by the groups that thought that the wetland was going to be affected, and we drilled back underneath it, and it really created a great opportunity to get this line done and make sure that this force main could be attached to that new facility. So it was a big challenge. We managed to get it done. For the testing of large diameter, we sent smaller samples to the barges, and every morning they would test the process and then look at the joint integrity by destructive testing to make sure that fusion process was working good. Because once we knew we were putting this pipe in, it would be very difficult to get out.
Richard, good job. I just wanted to say we got 5 minutes left and we're going to end on time. Dan, could you just tell us what the routine is once again for people to get their proof of attendance?
Yeah, at the conclusion of the webinar, a survey will be popping up. Please just leave your first, last name, and your state of registration, and we will get that over to you.
Thank you very much, Dan. Take it back, please. Alan Ambler.
All right, so there were lots of different things that happened on this Belgrave Water Pollution District job, Richard, as you mentioned. So here you're seeing this pipe being held in an elevated scenario. That happened to be to allow insertion into a casing for horizontal directional drill underneath the wetland. Go ahead and advance for us there, Dan, as we come through. Here you'll see more of it. So they were limited a bit in the ability to stage. Is that what I'm looking at, Richard, here? So
yeah,
that's
what we're really doing there is we're going back in through the box that was going to be where the effluent water or the treated effluent water would come out. So we had to go up and then down into it. The valves weren't put into the trench box yet, but we had to come up and then down, and that's why that pipe, and that just gave us really good direction to be able to slide that pipe down and not create any damage, and then start the pull back from the other side.
Go ahead and advance. There you go.
Yeah, there it is. So there's the outfall box or vault, and then we had that, and then what they did is we cut off that outfall tube and or where the insertion tube, and then sealed that up, and then the valves were put in because the valves needed to be below a certain level so you wouldn't get any sediment or disturbance of the water around that outfall box.
Go ahead and advance.
And then this was the last component of the two pulls, one line connection to the plant, and then of course the other side's there, and that was the fabricated fitting that was fused on to complete that run.
So the sweep on that fabricated fitting had to be properly designed and then sent to the fab shop. Is that right, Richard?
Yeah, that's correct. We actually put the pipes in first, then provided the measurements to the fab shop to get that custom sweep done.
Advance.
All right, 2-minute warning, fellas.
Absolutely. So here again is everyone that we participated today. Rusty, Pete, Jared, can you guys come on? Do you have any last comments and concerns or answers from what you've observed today? So Richard or Rusty, we'll start with you.
Yeah, I just wanted to say, thank you everybody for joining. I hope it was helpful and educational. And again, my email address is right there, or our website is www.coreandmain.com, and you can find the closest branch to you there. And again, thanks for the opportunity, ASCE and PE Alliance.
Yeah, well, Rusty, you're welcome, but thank you to you guys, you and WL Plastics, for sponsoring this with us. In our audience, please contact our engineers, Dan Landy primarily, and Alan Ambler, when you have your questions on projects, and we will help you manage through those projects. We will answer all your questions and help in any way we can. And Jared, great job. I'm so proud of you guys in Omaha for doing what you're doing. And with that, I will say to everyone, we'll see you in the next webinar. Thank you so much for your support of this important program.
Thank you, everyone. Have a great rest of your day.